Graphing linear inequalities. Well, the first thing you need to know is what are inequalities. So I've created a chart here that tells you what each one represents and how it will be used when you're graphing. So for the less than and greater than, some people still have problems identifying those. For me, less than looks like an L. I know that's a stretch, but that's how I remember it. And less than starts with L. Okay. And then greater than is the opposite. It's not necessarily like it's a backwards L, but like the less than, it starts off small and then it goes bigger, and the greater than starts off big and it goes smaller. So that's another way that you can look at it. When you're graphing, this is important to know. If it's less than or greater than, you're going to have a dashed line. And the reason I said a line is because we are specifically talking about linear graphs. And in the word linear, you see the word line. So when you are graphing, that's the shape that it should look like. It should be a line. In addition to graphing a line, you're going to either shade above or below based off of what your inequality is telling you to do. And there are instances where you're going to shade to the left or to the right. And that's typically when it's like x is less than a number or x is greater than the number or the other two inequalities, the less than or equal to or greater than or equal to. So the difference is at the bottom of the less than or greater than symbols, you see a straight line. Well, think of an equal sign. An equal sign looks like that. So all we're doing is just taking off that top portion of the equal sign and replacing it with either the less than sign or with the greater than sign. And that just tells you that your point or your information is going to be included. And since this is a solid line, when you're graphing, that's how you can remember when to use solid and when to use dash. And it's the same concept as far as shading. It's either going to be below or above. So that's a good chart to put in your notes. Also, you want to recall the slope-intercept form, which is shown here. And the reason you want to recall that is because your slope, which is in front of your x, and usually shown as a fraction, but if it's not, you can make it a fraction by just simply putting a 1 under it. And that's going to help you because when you're graphing, it's going to tell you how far you go up or down. That's considered your rise. And then the run is whether you're going to go to the right or left. And that's determined by the sign of the number. Your y-intercept is the part that's after your x. If it is not in this form, it will be very helpful to go ahead and put it in that form. Once you put it in the form, these are some steps you can write down in your notes. You want to identify your slope and your y-intercept. The first thing you do when you're trying to plot your points is go straight to your y-intercept. From that y-intercept, you can start using the points from your slope. I'm going to show you the 2 points that I typically use because you don't need a whole bunch of points. You know it's going to be a line. So 3 points are good. 2 points are good, actually. All right, so refer to your inequality sign. And that's helpful because that's going to tell you whether or not it's going to be a dashed or a solid line for your graph. And it also tells you the shade type. Are you shading above or are you shading below? Once you finish graphing, you want to check your points, and I'm going to show you which points I use. And the reason you're checking them is to ensure that you did shade correctly and that you have the correct line type. I do want to caution you, there are times when you have to divide by a negative coefficient so that you can put it in the correct form. When that happens, your inequality sign will change directions. So here I started off with a greater than sign, but my actual answer resulted in a less than sign. So when I'm going back to check my work, this is the one that I am paying attention to. So let's get started. Example 1, the first thing I want to do is identify my slope, which is shown as a whole number, but I'm going to make it a fraction. So 7/1. And I know this means rise over run. So what I usually do is I'll just draw little arrows to remind myself I'm going up and I'm going to the right. In addition, since this is a positive 7 and a positive 1, why not do a negative 7 and a negative 1? It means the same thing if I were to divide those negative signs out, right? It's still going to be 7/1. But this time I'm going to go down first and then I'm going to go to the left. Those are just two points that I can use on my graph. My other point is my y-intercept, which is the part after the x, and that's going to be -3. My line is determined by my inequality. So it's a less than or equal to, and I see that solid line. So I know that this is going to be a solid line graph, and the shade is going to be below because it's less than or equal to. So once I am plotting my points over here, I am going to go immediately to my y-intercept, which is -3. 1, 2, 3. And from that point, I'm going to go up 7 and then to the right 1. And remember to count your origin. Some people skip that for whatever reason. Go back to your y-intercept and count down 7 and then over to the left, -1. And what you will see is that you have just created a line. So that's why I said 3 points is more than enough. Now I know it has to be solid, so I'm just going to go ahead and draw a solid line. And these notes are helpful for me because sometimes when it's dashed, you're going to just want to draw a solid line because you have a ruler. That's just, you will just normally want to draw a straight solid line. It's also telling me in my notes to shade below. So that's what I'm going to do here. This is shading below. So that's telling me all the points below that line are included in this inequality. And all the points on the line are included in this inequality. So let's check and see if that's actually true. For me, I always use these points. I use my origin and I use my y-intercept. So the y-intercept has to have 0 for your x value. So what I do is I go back to my inequality and I check my work. So I substitute the zeros in for x and y and see if that's true. So when I multiply this 7 times 0, of course, that's going to go away. And now is 0 less than or equal to -3? Well, we know that that is not true if we were to do a number line. So 0 is over here and -3 is here. And as you go to the right, it's getting bigger. So 0 is not less than, it's actually bigger. So if that is not true, that means that my origin is not included in my shaded area. So if I go back to my graph and look at the origin is on that side. So that means that side should not be shaded. So far I'm on the right track. And then I go back, I go to my y-intercept and my y is now -3. I still have a 0 for my x. And I'm asking myself, is this true? Is -3 less than or equal to -3? And because of that equal to portion, then I already know my answer is yes, it is. So if I have a check mark for my y-intercept check figures, then I know it's going to be a solid line. If there was an X there, it will be dashed. So far my graph looks good. Let's go on to example 2. And I'm doing the same thing. I am trying to identify my slope. Sorry. My slope is 2/3. And I know I'm going up and I'm going to the right. My hand is always hitting something. Then I'm going to take -2 and -3. And I know I'm going down and to the left. And my y-intercept is +4. If I'm looking at my inequality is greater than, it does not have that equal to part. So I know it's going to be dashed. And greater than means above. Going to my graph, I'm going to go to where y is 4. That's my y-intercept. And that's my first point. From there, I'm going to go up 2 and then to the right 3. Go back to my y-intercept, go down 2 and to the left 3. Again, I should see a line, but this time my line is going to be dashed. So make sure you have erasable utensils because you're going to try to draw a solid line. I'll tell you, watch. Okay, because I know I do it all the time. So that is going to be my dashed line, and I am, based off my notes, I'm supposed to shade above. So let's see if that's true. And let's check our check figure. So going back to my original inequality, I am going to substitute 0 in for x and y. And that's going to leave me with 4. Is 0 greater than 4? No. So that means the origin is not included. So let's go to the origin. I did not shade it. So far I'm on the right track. Now 4 should be greater than 4. Is that true? Well, no, that's not true because it does not have that equal to sign. So it should be dashed, and my line is dashed. So 2 for 2. This time I see that my actual inequality is not in the slope-intercept form. So let's go ahead and do that first. And I also see that I have some systems here. So I'm going to color code it so I can keep track of which is which. All right, so the first one, I'm just going to move that 3x over to the other side. So that results in negative 4y is less than negative 3x. And I always put my x first so it's in that slope-intercept form. But there's already a plus 8 there. So now what I want to do is divide both sides by this negative 4. And that means everything has to be divided. I am left with y, and this is where I was telling you earlier, you have to, when I cautioned you, you have to change the sign because you're dividing by a negative coefficient. Those two negatives go away, so they cancel out. So I'm left with 3 over 4x. 8 divided by negative 4 is negative 2. This is the function that I am referring to when I check my work, not that one. So pay attention to that. All right, so let's go ahead and look at our slope, which we said was 3 over 4. That means up to the right. And then negative 3 over negative 4 down and to the left. So you may say, well, what if there's just if you have an instance where one of them is negative and the other one isn't, then I just flip it. So the first time the numerator is negative, the second time it's not. The first time the denominator is positive and the second time it's not. So there's my 2 points. That's what I would do if one was negative and the other wasn't. All right, back to my y-intercept. It is going to be negative 2. And the line for this one is going to be, because it is a greater than symbol, that means it's dashed and it's shaded above. So now let's change colors here because, again, now I want to focus on the second inequality. And that one's straightforward. It's just telling you all y values that are less than or equal to, or all y values are going to be less than or equal to 5. So that means it's going to be solid because it has that equal to portion, and less than means it's going to be below. Going back to my first inequality, if I go to my y-axis, I'm going to look for negative 2. There's my y-intercept. I'm going to go up 3 and then to the right 4. Oops. Make sure you're including that origin when you're counting. And then I'm going to go back to my y-intercept, go down 3 and to the left 4. Again, I am creating a line, but this line is dashed. So I want to keep that in mind. That's why I like putting my little notes there, because otherwise you're going back and forth, trying to see what am I doing. And I'm shading above according to my notes. And now let's go to the other one, my second one, which is y is less than or equal to 5. So I'm going to go to where y is 5 on my y-axis. This time it's going to be a horizontal solid line. And I am, according to my notes, I'm shading below. So everything below where y is 5. Now, what you are looking for is where do they actually overlap? So my yellow and green, this little section, all of this, that's overlap. That's what I'm focused on. Now, I also want to check to make sure I did this correctly, but when I'm checking, I don't have to worry about this one because that one, again, there's nothing to check. For the one that I had to put in the slope-intercept form, I'm going to replace my x's and my y's with the zeros. So 0 should be greater than negative 2. Is that true? Yes, it is. And again, if you need to do a number line, then do so. This is referring to the green one. So this is the green graph. And this is saying that I should have included the origin. So for the green graph, is the origin included? Yes. So that's my shaded area. That part is correct. And then I'm going to now change this y to -2. Is -2 greater than -2? No, that's not true. Why not? Because it does not have that equal to sign there. So therefore, that means it should be a dashed line. So the green line should be dashed, and it is. Again, I don't have to check anything for my yellow one. And you see how I'm color coding? Because it will get confusing. So keep track of that. This is the last example. And I'm going to do the same thing, color code here. So I'm going to use green, blue, orange. All right, so for the first one, it's already in slope-intercept form. So I'm going to identify my slope, which is 5/3. My y-intercept is -6. The line type is based off of my inequality. So it's greater than or equal to. So that means it's solid because it has that line under it. Greater than means it's above. My second one is showing me that it's less than. So if it's less than only, that means it's dashed and it's below. And then the third one, I have an X here. So that's either going to be left or right. And it's greater than. So therefore it's going to be dashed. And so X values are all bigger than, so that means it's going to the right. So let's go and get started with that first one. So we're going to go down to -6 on our y-axis. We're going to, from there, go up 5. I forgot to write it over to the side, but I know to do it. I'm just used to doing it this way, but just to help someone else out. Okay, so go up 5 and then to the right 3. Go back to your y-intercept. That's your starting point. Go down 5 and to the left 3. I am going to have a solid line according to my notes. Sorry, my hand hit something again. And it's telling me that I'm going to shade above. So everything is shading above here. Going to my second inequality is telling me that y is going to be everything that's smaller than -2. So I go to where there's -2, and this is going to be a dashed line. Let's try to freestyle this one. Okay. I did okay there, except for that arrowhead. Oh, oh my. There we go. That's good enough. All right, and I am going to shade it below. So everything below. And then finally, we're going to go to our third one, which is where X is bigger than everything that's negative. Okay, X is greater than -3. So I go to -3, which is 1, 2, 3 right here. This time it's a vertical line, but it's still dashed. And X is everything bigger than that, which means it's going to the right. And what you are looking for is where the region where they're all intersected. So let's see if we can highlight that. So I see the blue, I see the green, and I see the orange all in this little section right here. This is the point where they're all shaded together. So let's check to see if we did this right. I am only checking this one. There's nothing to check for the other two because they're self-explanatory. So I'm going to replace the X and the Y's with 0. And so y should be greater than or equal to, well, the 5/3 goes away when you put a 0 there, -6. I'm sorry. I said 0, right? So 0, is 0 greater than or equal to -6? Of course not. So that's not true. That means that the origin should not be included for the green one. So if I go, oh, let me see, did I do something wrong? I know I did. Let me see, 0 and 0. I did it again. That is true. I don't know why I keep doing that. This is funny to me. Okay, so if you're like me and you're just, I don't know what I'm thinking, it's going this way. So of course 0 is bigger than -6. Well, I don't know what I was thinking. So yes, that is true. So that means the origin should be included. So let's see for the green graph. This is what we're referring to. That's why I was color coding. Is the origin, let's change that so you can see for the green one. Yes. So that part should be shaded for the green based off of my checkpoint here. So now when I substitute back in for my y-intercept, this is asking if all the points on that line actually are included. So I'm going to replace my y this time with -4, and it should be greater than or equal to -6 if it is a solid line. Again, if you are like me and sometimes you just, I don't know, have a brain malfunction, write it out clearly. -4 is bigger than -6. So therefore, it should be a solid line. Okay. So that's the easiest way to check your work to make sure that you are on track. And again, that's only for the green. I didn't have to do anything for the other two since they didn't have an X and a Y in the same equation. So I hope you guys learned something there and how to check for your mistakes because, you know, this is a lot going on. You could make some simple mistakes. So it's okay. We're doing this together. We're learning together. Go ahead and thumbs up for me, please, and subscribe.